Hello, everybody, and welcome to today's presentation. Serverless functions on DigitalOcean using OpenFaaS framework, brought to you by DigitalOcean. I would like to introduce you to our presenter, Vivek Sridhar. Vivek is a tech enthusiast with over 11 years experience in the software industry. He is currently working as a developer advocate with DigitalOcean and has been a technology advisor to several tech startups. Previously, he was head of DevOps and QA at Blackbuck and was a DevOps solution architect at HCL Australia in client engagement and pre-sales roles. Vivek started his career with IBM Rational India Software Labs and is passionate about working with software developer communities.
Today, what we are going to discuss is how we can, put a serverless function on DigitalOcean. And before that, I just want to introduce myself. I'm Vivek Sridhar. I'm a developer advocate at DigitalOcean, and I was head of DevOps at Blackberg and also a DevOps solution architect at HCL Technologies. And worked as a software developer for IBM India Software Labs, and I pretty much work on DevOps and cloud architect. And this is my Twitter handle at Vivek_Sridhar, and that's about me. So what we are going to discuss today is, say for example, you have a API and you are hosting an API on a particular infrastructure, and that is serving some traffic, serving some service, and there is a traffic onto this API and it is consuming some resources. Then you want to strategize this particular API into three different buckets. And one of the bucket would be, if there is a lot of traffic onto this API, there would be, you want to scale this API, and if there is less traffic onto this service, then you want to scale down this API, and you don't want to create more instances, but you want to have only one instance of this API. But with a lot of traffic coming onto this service, you want to scale it up. And and the third bucket would be that you don't want this service to be available at all. So whenever there is a requirement, whenever there is a request coming for this API, you just want to create a new instance of this API and use it. So basically, what you're trying to do is you're trying to manage your resource smartly, and you want to make sure that this API service is scalable and also manage the resources properly. Then you're looking at having a serverless environment, having a serverless infrastructure onto your strategy. So to do that, you need various things. One, you need a simple serverless framework, which is having a language support, and most of the language support, and also having the support for cloud native metrics, and also operator friendly and easy to build, deploy your code. And that's what OpenFaaS provide today. OpenFaaS is a open source serverless framework, and it provides these capabilities, and we will see a demo of this. Apart from that, you need a simple cloud platform where you can get started with cloud native tools, like Kubernetes. So this solution provides Kubernetes, today, and it's several users are using Kubernetes as a beta access. And Alex is one of the OpenFaaS founder who actually uses Kubernetes in building and deploying his functions. So let's go and see what OpenFaaS is, and see what is the architecture, what are the components it requires, and other stuff. So OpenFaaS is a functions as a service. and it's a framework. Basically, it's kind of a framework. It has a very good support for Docker Swarm and Kubernetes, and it also has a cloud native metric support like the Prometheus inbuilt into it. And there is a very good support for packaging stuff. Like they have a inbuilt function store where there is already pre-built functions which is already available, and these functions can be reused. And if you have a requirement to reuse these functions, you can go ahead directly and reuse it. And we will see what are those functions as well while we are doing the demo. And it has a very good support for UI, and it has very good support for different languages and other things. We will deep dive into what are the components, functions, these OpenFaaS as a functions as a service provide. And one of the component is API gateway. So API gateway is the external hosting of these functions. Say, for example, you create 10 different functions. It is available on this API gateway, and it is external endpoint to access your functions. And each and every function has a watchdog HTTP server, and this function watchdog is hosted on each function which you create. So we will see what is the functions and what are those, what do I call as a functions, everything when I do the demo and the next slides. But to understand it in a high level way, function watchdog is just a HTTP server which is hosted on the function. So basically, for each function, it is the entry point is on the watchdog, and for all the functions, the entry point is on the API gateway. And there is a support for Prometheus. We will see, how Prometheus is used while building your auto scaling capabilities and other things. And there is this, support for Docker Swarm and Kubernetes, and everything is built on the Docker. So basically, most of the services are built on the Docker. Everything you build, every code you write is converted into a Docker image and then deployed. So one of the best and the best feature of OpenFaaS is that it provides a very good support for all the languages which is available today. So if you are a Go developer, you go and design products or the functions in Go, and also you can design functions in Python or in Node.js. If you have a developer who likes to write in PHP, you can go ahead and write it in PHP and write and deploy these functions. So you can access DigitalOcean current report and see that there is a list of top 10 programming languages which is available today, and most of these languages are supported in OpenFaaS today. And any language can be used to develop different functions and can be orchestrated into single function and can be deployed as a microservices as well. So this is about the language support it provides for deploying a function. So let us go with the step wise, how to write a function and what steps it will you need to take to write this particular function. Once we have deployed the OpenFaaS framework into Kubernetes and also install the CLI, the FaaS provides a CLI capability. So the FaaS CLI to create a new function is FaaS new language Python 3, and activity finder is a simple simple function which I am trying to create. So I have make a note of the Python 3 language which I am using here. So that Python 3 language is nothing but a template which it provides. There is I talked about the template it provides. So basically, when you create a Python 3, it creates a template of handler.py and requirement.txt and different structure of file system for which is required for Python 3. So if you are a Go developer, you just give a language Go and it creates a Go template. If you give a Java, it creates a Java template. So in Java, you might see that it is like source, main, com, and everything. So similarly in Go, it will be handler.go. So different templates gets created for different languages, and once you create these templates, you can write code which you want to design the business logic which you are designing for a specific API. So for example, I've just designed a simple API where I have put all the activities what DigitalOcean does today and into a simple JSON format, and calling that JSON format and just printing that, just printing that and returning that particular information. So you notice that it has something called as import request. So import request is something, is a module and that module is also being updated into the requirement.txt. So this is a simple design. So what your business logic is written in the handlers.py, and if you have something external stuff, you put it into the requirement.txt from the Python template perspective. If it is a Java, it will be different. If it is a Go, it will be different. We will see an example of that as well while I'm doing the demo. But this is the first step where you just create a new function and you add two different, you update two different files. So what will be the second step? The second step is pretty simple. You are going to build, push, and deploy these functions. So when you build a function, what happens is, the template file of the handler file gets built into a Docker image. It creates a Docker image, and then it gets, then you can deploy. When you push it, it pushes to the registry, and when you deploy, it deploys to the gateway, or that is on the watchdog. It deploys on the watchdog onto the Kubernetes or the Docker Swarm, whichever orchestrator you're using. So if you notice the activity finder.yaml, which is again YAML driven, and which is which you can see here that there is different set of configurations available here. So when you're building, you use this configuration and then build the function. So while building, you will check for which language and where is the handler, and then create a Docker image of it. And while pushing it to the registry, checks where the registry is. It could be a private Docker registry, it could be a public registry like Docker Hub, and it checks for that when you are doing a push, and it checks for the gateway where you're pushing this particular thing when you do a deployment. So we will see all the three different formats when we do the demo, but this is the basic architecture, basic steps which you need to take to write a particular function. All you need to do is create a new function and write your business logic into the required template, and then just use build, push, and deploy onto the YAML file which is already been generated. And we will see obviously this gateway will change when you are deploying these things to the Kubernetes and other places. So this is this is a simple diagram which has been put out by the OpenFaaS team, which is like you have a gateway, and that gateway is nothing but an external external entry point for your function, and that is being deployed onto Kubernetes providers, and then those functions are available here. And when there is a lot of traffic coming into on top of this function, there is a Prometheus available, and on to Prometheus you can scrape the metrics, you can see the function invocation counts, and if it is high, if there is a lot of traffic, if the invocation count is increasing, then there is an alert manager in Prometheus which will alert the gateway to scale up the function. And that's what the first part of the bucket which I was talking about at the first slide, where it can scale the function whenever there is a requirement, and it can scale down when there is no traffic coming into this particular function. And then you can even zero it to keep it to 0, and whenever there is a requirement, then only spin up a new instance of these functions as well. That is the third bucket. So obviously these all functions are deployed onto the watchdog, and there is there's a Docker image, and there's a function, latest functions, which is again you're deploying through a Docker image itself. And this watchdog is something, is a simple HTTP HTTP server written in Go, which is hosted on top of each function, so that it can scale, it can provide the health of the functions and other things. So pretty much this is the architecture of the OpenFaaS, and these are the components of the OpenFaaS, and we will see all these things when we do the demo part of it. Let me go to the demo, and then we will take questions later. Okay, so there are two things about while doing this OpenFaaS. One is you need orchestrator, that is either Docker Swarm or the Kubernetes part, or you can do this with the Docker Swarm. But we will be doing with Kubernetes, and there is OpenFaaS is already available. So let me create a new Kubernetes cluster. So I'm going to create a new Kubernetes cluster here in DigitalOcean. It's in a limited access as of today. So it has support for all the versions which is available today. So this is the latest version. So I'm selecting the latest version, and you can choose the data centers, different data centers which is available. So you can choose it on different data centers. So I'm choosing Bangalore data center, and you can see that you can choose the node pool for your Kubernetes cluster. So I'm just choosing an optimized node, and there is a different $80 plan which I'm taking up, and I need only 2 nodes to run this particular dev environment of OpenFaaS. Okay, and obviously you can add tags to it. So say we will name a tag called OpenFaaS demo. So I'm choosing a name 006 KH. So that is for just to name of the cluster so that I can easily map it. So let me create the cluster just to cluster is getting created. While cluster is getting created, let us create a droplet where I have done some customization. So it's available in a snapshot. So I'm going to the images, and I'm going to the snapshot, where the snapshots are available. So I've installed the kubectl already installed. I'm just creating a droplet from that. Droplet is nothing but a virtual box. I'm just creating a droplet from that virtual image which I've created. So this is the image, and I'm choosing the size of the image from a standard droplet, and CPU optimized droplets are available, but I'm just choosing the standard droplet to access the Kubernetes cluster and perform some of the development on OpenFaaS. So I'm not doing any block storage or backups as of now. The block storage is required only when you're doing some IOPS activities. Then there is data center which I'm choosing, and it's already chosen. This is monitoring is enabled, and I'm choosing SSH to log in. Let me name this as and I'm adding to a project. So project is nothing but, is to group all your resources into one, like compute, network, and storage is grouped into one specific, project, so that all the resource you create on DigitalOcean is under a certain project. So let me create this droplet. While this is creating, let us check the status of Kubernetes cluster is still provisioning with 2 nodes. Let us wait for it to get provisioned. Cool. So cluster is provisioned, and you can see there are few things which you can do with this. There is a settings. If you click on these settings, there will be different. You can destroy cluster. There is nodes. You can increase the nodes, and also you can see that some of the overviews or some of the steps has been provided that you can follow. And let me go back to this. So very important, it has a automatic configuration file. We create an auto configuration file. All you need to do is to download configuration, and let's see if the droplet has been created. Droplet has been created, so I'll just copy this, and we will go ahead and okay. So we will go ahead and copy this particular what is the file name? Oops. Okay. This is 6. Okay, let me do this. SCP 006. I'm copying it into that particular temp. Okay, so I'm copying that configuration which I downloaded into the droplet which has the kubectl already installed. Okay, so I've just copied it, and let me go ahead and SSH into that box. Okay, so I'm just SSH into that box. I've just copied the download file and SSH'd, and now I will just export that particular configuration. So export kubeconfig, and you just need to config export, but this is not the best practice. You can also add it into your home, your user home. So I'm just exported it. Now kubectl get nodes. So my Kubernetes cluster is ready, and I am able to access the cluster. And it is because it took around 10 minutes or 5 minutes to get started with my Kubernetes cluster. So now all I need to do is to create OpenFaaS services on this cluster. So I just will just create them, and I'll just copy the FaaSnet, which is the Kubernetes cluster provider through YAMLs, but this is a dev environment. So I'm just creating a dev environment settings here just for the for the demo purpose. For the production purpose, you will have to use Helm charts and other installation steps which is required to make sure it is a production oriented OpenFaaS you're deploying and you're using that for your production. So I've just downloaded that FastNet. So we need to run, we need to create two different namespaces for different services which we are going to deploy. So that I'm going to apply the namespace.yaml, which is available in the FaaS.net, FaaS-nets. If I click on this, there's two services which gets created, two name services. One for OpenFaaS service itself, the other is for functions which we are going to deploy. So okay, so other which is for the functions. Let us go back and run this YAML so that we can deploy the complete functions here. So basically, if you go into this folder, you will see that there is a YAML, a YAML directory, and if you go into that YAML directory, you can find a lot of YAMLs available, and these are the YAMLs which has been written to deploy these services onto Kubernetes cluster. So let me deploy it. So I'm just applying some of the Kubernetes things. So let me deploy this. So all the services got deployed, the alert managers, the gateway, which I was talking about, the NAT services, the Prometheus, and queue workers and other stuff, and also role-based stuff, which is required for your security and other stuff. So it gets deployed. Let us check whether it has been deployed. kubectl will get service hyphen namespace OpenFaaS. We created an OpenFaaS namespace when we wanted to deploy this specific OpenFaaS service onto Kubernetes. So I'm just checking this. So you can see that most of these services has been deployed. So alert manager is here in a cluster IP. Gateway is available on node port, which is accessible outside, and Prometheus is also accessible outside. Okay, so for doing auto scaling demo, I need Grafana. I need to show you how exactly the functions work. So I will install Grafana also onto this, and these are the few steps to do that. And these steps are well documented in the OpenFaaS workshops and OpenFaaS documentation. So please visit that if you want to understand what each command does. So Grafana has also been deployed on node port, and it is available on different ports. These are the ports where I can access these services. So let's go ahead and access some of these services. So to access these services, you need to copy any one of the the cluster nodes which was created, any one of the node IP address, and then all you need to do is to provide the port for that, and the port where the if you see this port number 3112, that's where the gateway is being hosted. That is the OpenFaaS service UI is hosted. So if you see, the OpenFaaS UI is available now on that particular port. and you can deploy new functions. Even before we deploy functions, we will go ahead and see Prometheus as well, which is hosted on 3119 port. The Prometheus is available here. Okay, and let me show you how we can set up the Grafana as well. So now Grafana is also up and running, and we can see it has already inbuilt dashboard for OpenFaaS. Sorry for the delay. Okay, so let me log in as admin, and you can see that we can access. Here is the dashboard for OpenFaaS. You just need to select this OpenFaaS. Okay, so you can see this Prometheus, and there is alert manager already looking for high invocation rate. If there is invocation rate, and then it will look for some of the activities it can do through alert managers. So let us go back to the OpenFaaS portal. So this is OpenFaaS portal. We have deployed that on Kubernetes now, and we will create a new function from the portal. When I click on the new function, it opens the store. So this is the store which I was talking about. It's already has an inbuilt functions. You could make reuse of these functions, or you can also you can also contribute for this store through contribution channel, and people can reuse your functions for various different activities. So some of these functions are available here, and I am just picking one, which is node information, which is from the get info about a particular machine on which it is being deployed, and it gives you the CPU count, host name, uptime, and other things. So it's a simple function which has been written for a demo purpose. So we'll deploy this function onto the OpenFaaS portal, through OpenFaaS portal onto the Kubernetes. This is already deployed. So it's already deployed. It's still getting deployed. Some of these things has been it's still building it. So we'll have to wait for this button to get enabled. So once it's enabled, we can access it. And if you can see that there is a status which is ready. That means at any point in time, this particular node function is available. So I was talking about the third bucket when I spoke about the first slide, where you don't want this particular ready state at all. You're looking for this API service which is in the cold state, and if there is a request coming into this service, then it get into a ready state, and replicas gets created. So this is the third bucket of that particular API function. So this is the invoke. If you invoke, you can see that there is a response and there is a round trip. That is the time it took to respond, and there is some of the, this is the URL to access the function. This is the invocation count which I am talking about. You can keep invoking this function, and you can see the invocation count increasing here. And obviously you can see some of these on the Grafana portal, and also on Prometheus. To run this on Prometheus, you need some query from SQL query. So this is available from QL. So we'll run this, and you can see the graph coming in. So I'll make it. So you can see the graph coming in. So this is the Prometheus stuff. So this is a simple setup where you're deployed an inbuilt function, and we will see how to do, how to build and deploy a function which, in a more usable way. let me log into server again, and here what we will do is I'll show you some of the we'll install the CLI first before we get into detailed discussion. Let me do the CLI. So these are the simple commands which is available in the workshop, where we have provided the through handout, webinar handout. You can don't get access to all these commands. It's available. While it is downloading, we'll also download this. So it's downloaded, and let's get FaaS CLI. So this is a CLI component of OpenFaaS, where you can perform some of the actions which I showed you on the UI. You can perform the similar kind of actions here. So this is something which is available. So let us wait while it downloads. Perfect. Now it's got downloaded, and then we will create. Well, I'll show you the most important thing about OpenFaaS was the okay. I'm not pulled the templates, so I'm pulling the templates just to show you how this template looks. Okay, so if you go and do execute FaaS new list, it will show you all the language templates available today. So basically it has Go, Java, Node, PHP 7, Python 3, Ruby support. So most of the programming language is supported here. And if you don't have, if we don't have any language support, then you can directly write a Docker file. So you can directly create a Docker file and then get started with your function. So basically, it can support any programming language if it is supported in the Docker, right? So that's the part of the service. And let me create a new function. Okay, so this is to create a new function. We have already seen this command. All we need to do is to change some stuff here. We'll do as request 006, and we'll create a simple API which is requesting something, and you're getting a response from this. So we will create this, and it got created under this folder itself. And these are the two different files which has been created. And as I told you, let me show you creating a different language as well. Let me log into different, and then we will create Java 8. So if there is no template, it will download the template into the folder. So basically it creates these three different files. One is the YAML, where YAML file to create a service. And let me show you what is the structure of the Java 8. So basically it has created two different Java 8 is not available. It created with a different structure. Second, FaaS list. Oops. Once that, oh, FaaS new list. Sorry. Java 8 is there. Oops. I did this mistake. So I need to have created with Java 8 hyphen request 007. Okay, so I'm sorry, it's my mistake. So let me clear this out and I'll show you this. Okay, this was supposed to be running, so I missed this. I missed the name of the function which I was creating. So let me go here and see this. It has created a request 007, and request 007 will have different settings. Okay, so this has a completely different folder structure. This is a template for Java, and this has very different folder structure, and there is a source and different things which is available. Okay, let me go back to request 6, which was a Python template, which is handler.php py, and let's open this, and we'll write some code which is written something hello DZone. Okay, and we'll save this, and now we have handler ready. If there is nothing to do in the requirement.txt, so we don't need to do anything, and we have the setup ready. We have to open the request6.yaml. When we open the YAML, we have the configurations for that. We already have, we know that it is on Docker Hub. It is a handler here. There's a language support, and there is a gateway. So gateway is a different thing. The gateway is hosted here, so which is which is on Kubernetes. So we need to change the gateway path. So we need to go here and make those changes, and we will make these changes at this location. Okay, and now I'm going to save this. Now we have the YAML file setup ready, and the request handler is ready. All we need to do is to deploy. So to deploy this, we use FaaS build -f, and then the YAML which we have. Okay, so the YAML which we have, we just need to build it. When we build it, a Docker file is getting created. So so basically Docker file is getting created with the handler which we have used. So we have used Python. So Python handler is used to build this particular Docker. So both the images is been built. Okay, so we have built the built the thing. We can see that here there would have been everything is up. Now we have to now we have to push it, but we cannot push it unless and until we have logged into our Docker registry. So let us log into our Docker registry, and okay, now I have logged into Docker Hub, and you can also see there is a build folder here. This folder has the request 006 up and running. So this is the Docker file which will be available there. That is the Docker file for which the build is we have built it now, which has the handler and then the template. Okay, now we need to just push this particular image to Docker Hub. where I have my registry. So I'm just pushing it. This particular file will be pushed. Um, Once the image is pushed, we just need to deploy the function to Kubernetes, and it will be deployed over the gateway for Kubernetes which we have provided. So, okay, all I need to do is just change this and say deploy. So this is deployed on Kubernetes cluster. This particular function is up and running now. You can see this. This is the path to access it, and also you can see that on this where request 006 is available. You can go to this request. Yes, of course, it is taking time to build and deploy it onto this server. It's been done now. So all the parts of the application is ready. So hello DZone is available, and invocations and replications is available for that function. So this is the response which we wrote. So this is available for us to get started. So all we need now is to test how this auto scaling stuff works on this particular function, where we have created some of these functions, and when we create when we generate traffic onto this particular API, how the auto scaling works and how it works in Kubernetes, and how you can scale up and scale down. That's the first two buckets which I was talking about. So let us go and do that. Let me go back to this and let me open another tab, and let me log in to the server. Let me log in there. Okay, so I've just logged into this server. All I want to do is to run some command so that I can generate request. So on the other servers, let me okay, this is where I'm not set it. kubectl get nodes. Let me export itself, and now we have kubectl get nodes. It's working. Let me create the same. kubectl cs. Okay, now we have to set up ready. What we will do now is run a particular command, that is this particular command, but that is not the path of the function, so we'll change the path of the function. So let me go back to OpenFaaS portal and copy the path of the function, and we will post it here. And just run it in the background. So now we can see this generating a traffic to that particular function. So it's getting generated, and we will see that here invocation is number is increasing, and you can see that in even in uh, Prometheus the function is getting increased, and you can also see that on the Grafana dashboard as well. So you can see it on various dashboards. It's been increasing, and you can see there is a 4 replicas also being created. So where I can see that is here. Uh, you can get pods, namespace, OpenFaaS, FN. So it's where all the functions has been deployed. So if you see the node function is having 4 different replications, and you can time to time you can check that this invocation is going above 600, and it's already 4 replicas which is running for that particular function. So basically you can see that you can scale up and scale down of this particular API when on demand. So you're creating a demand, and it is scaling up, and it is we will see how to scale down once we stop the service. But if you see all the pods which is running, it's still at 4. It should be more now. So basically now it has scaled up more for accommodating the request which is coming in in every invocation which is happening here. So there is 1300 invocations, and it's pretty fast. So that's the reason why it requires such auto scaling structure. So when I go back and uh, stop this service, right? When I stop this service, let me go back to this again. Now you can see some of these functions will get terminated, some of these pods will get terminated. So if you see this pod is getting terminated, this is how you can scale down. Now you're scaling up, you're scaling down. You can also maintain a zero state. It is not in a always ready state. You can maintain a zero ready state. So you are utilizing the resources of the infrastructure pretty well for a particular service which you have deployed. So I could deploy a simple service, simple synchronous and asynchronous functions as well to run these kind of services. So basically all the pods get killed, and it comes back to only one replication now. So that's the that's the main thing about about the OpenFaaS, where you can auto scale and not auto scale down. But also you can notice that the similar thing would have happened on this on the high invocation rate as well. How this happens, we can check that part as well by running it again. We can see that in Prometheus it will start showing you if there is a high invocation rate coming in. Obviously, you can see that in Grafana, you can definitely see some of the spikes, which is the scaling, replication scaling, and the execution durations of each each of these requests which is there, and functions rate which is going through. And in Prometheus, we can see that some of the alerts. So here it's an active alert which is going on, and it is firing more replications. This is how it fires through an alert manager. So Prometheus is responsible for that. Let me go back. So I'm done with my demo. Is there any questions? I'm ready to take the questions. Hello.
Hey, we're ready for questions. Vivek?
Yeah. I don't see any questions there.
We have a couple that came in. We have a couple minutes for the questions. So audience, if you have any questions, please post them into the questions panel. The first question we have is, can I use load balancers with OpenFaaS on Kubernetes?
Yeah. I'll just show you how you can use it. So one of the thing about OpenFaaS is that you can deploy load balancers, and as I told you, right? So deploying OpenFaaS, sorry, OpenFaaS docs. Okay, so basically, if you see the OpenFaaS documentation, the deployment which I did for Kubernetes, right? So that is not the ideal way to do it in the production, as I told you, right? So it's more from the it's more from the, you need to deploy it via Helm chart and other things. So once you deploy that through Helm charts, you will be able to you'll be able to use the load balancers and ingress and also the securities, the other features which is there in Kubernetes. You can use that with the OpenFaaS. And also there is a very good article on from Alex himself, who is who is the founder of the OpenFaaS. He has written his first look on DigitalOcean Kubernetes. He has written how to use the load balancers with DigitalOcean, and how you can get started and other things. So you could use this blog post to set this up. You have other questions?
Yes, we do have another question in. It looks like we only have time for one more question. The question is, does OpenFaaS support async functions?
Yes. So the difference between the sync functions and async function is that if there is a sync function, all you're trying to do is you are requesting an information from this particular service, and you are getting a response. That is, if I request a node information, you are getting a node output. What is the response? What is the platform? What is the CPU count and uptime and other things? But if it is an async functions, what you do is you deploy these functions as an async function, and once you deploy this as a async function, then you're not waiting for getting a response. All you're doing is submitting a job to be run in the background, and you are finding the results from the other various ways like logs and other things, but you're not waiting for a response onto this. In OpenFaaS, async functions will be deployed as async here. If there is a function here, it means that it is a sync function. If it is an async function, then it will be async function will be displayed here, and that is again on the API gateway, which I talked about in the architecture perspective. There is the API gateway that it will be on the API gateway and not on the function itself.
Awesome. Well, it looks like all the time we have, Vivek. So I would like to thank you for a great presentation today. I would also like to thank today's sponsor, DigitalOcean, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.
Thank you, man.